Okay, so today is March 1st, and this will be our lecture. I'm actually going to put out two lectures today. The first is going to be a little bit of a review, a little bit of new stuff, just sort of going through some of the arena nomenclature and constructs and whatnot, way to get around the system kind of stuff. Because I've seen in a couple of the submissions that you folks have made that I'm not sure that piece of this is fully in place yet. So I figured let me review it a little bit, spend a little bit more time on it. Hopefully that helps. With respect to the submissions, I think I have everything. I do have everything from everyone on the first assignment. The second assignment, I don't have everybody's stuff yet. So if you can make sure you get that into me, preferably sooner than later, that would be appreciated. Again, first lecture today is going to be this sort of review and a few new things. And the second will be talking about queues and looking at queue sizes in decide modules rather than doing two-way by percentages. We're going to look at a variable and make a decision based on that. So that'll be the second piece, and then your homework for this week will be related to that. So, okay, so as we look at Arena, it's basically split into two views. The top view is the flowchart view, where you've got the graphics, you've got the little process modules, the create modules, all that flowchart type stuff. And you can edit most things directly from that. If you double click on a module, a window pops up, and you can edit the characteristics or parameters that are in place, the statistical distribution and whatnot that's being used. So that sometimes is the easiest way to do it. In other cases, it's easier to use the spreadsheet view, which is directly down below the flowchart view. And like most Windows-based things, you can make those windows bigger or smaller as you see fit. Many times, if you're looking at things like resources and you want to add a schedule, sometimes that's easier to do through the spreadsheet view rather than the flowchart view. But again, you can do it in either place, and it writes to the same database, so you're not you're getting to the same endpoint. And again, many things can be edited in either view. And with the horizontal splitter bar, you can change the size of those two views relative to each other. Okay, so that's the sort of the main functional area where you work with Arena, the spreadsheet and flowchart views. On the left-hand side, at least that's the way I've got it set up, and I think that's the default. You also have a project bar, which lists a bunch of different things. It lists panels for basic processes, for all different types of processes that may be utilized.
How many people heard you?
Okay, so again, the project bar on the left side of the screen, you've got the basic processes, advanced processes, flow processes, packaging, and advanced transfer, as well as the reports piece, which again is an easy way to get to the various reports that you might want to see. Most of the time, we're going to be in the basic process area, and if you can sort of follow along with that, if you click on basic process, you're going to have the create module, which starts off again every simulation, and the dispose module, which ends every simulation. And in between those, you're going to have a bunch of other things like process modules, decide modules where you want to make a decision on where an entity is going to go. Things like batching and separating, where you can batch a given number of parts for some specific process. And then when you're outside that process, you can either leave it as a batch or you can separate them back into individual entities. The clone module we've not used yet. We'll get to that later. The assign module is an important one as we talk about making decisions based on variables. The assign module is where you would assign various characteristics or attributes to variables and to attributes of the individual entities or of the whole system. So again, variables are model-based things and attributes are entity-based things. And the assign module is where you would assign a value, and then maybe increment or decrement a value as an entity passes through it. So we'll get into that a little bit more, but that's an important one that we need to understand, and we'll use that again as we go forward with this. The adjustable batch, haven't done anything with that yet. We'll get to that later probably. Record module is an important one as well, and that's for recording data. So if there's a specific piece of data that you want to capture that's not part of the normal reports that Arena has, you can do that through the record module, and then it will show up in your reports as a user specified characteristic. So that can be helpful as well. As we move down into that basic process further, you've got a bunch of different windows that you can open that are part of the spreadsheet window. So the top ones, the ones I've gone through so far, the ones that are in yellow, those are all on the flowchart side. The ones down below, those are all on the spreadsheet side. So if you were to click on attribute or entity, queue, or resource, variable schedule, any of those, you'll see a spreadsheet pop up in the lower window on the main screen. Okay, so again, the basic part of this thing is you've got the flowchart modules up above and in your left-hand toolbar, and the spreadsheet modules down below. The other processes are set up similar to that with the advanced process, and we'll get into a few of these as well. And the flow process, this is sort of a new thing to Arena with this new release, where you've got some ability to simulate some sort of a chemical process or whatever, and you've got some icons there that help to simulate that. Again, with the packaging module, again, similar to the process, you've got some unique icons that can be used for moving product around and showing it in a sort of a more realistic icon. So those two are new to Arena this year. And then finally, the reports module is the last, reports window is the last window there. And that basically brings you into your reports module, where you can look at, after you've run your simulation, there's various different characteristics that you can look at. Things like wait times, processing times, frequencies, number of entities through the system, size of your queues, resource utilization, and again, the user specified one, which would be done using the record module. So that's sort of a quick run through of that. I think it's something you're going to pick up better as you use it more. But I figured I thought it might be worthwhile to just sort of run through this again. Another window or bar that's on the screen is a status bar, which is at the bottom of the Arena window. And that just gives you some information relative to the run speed and number of entities through your system. Gives you the simulation clock value, which you can utilize again as a system variable and make decisions on. The number of replications that have been executed, in other words, how many entities have passed through the system, which is useful. And again, we set that normally when we initiate a simulation. And the key point there is that you have sufficient replications to be statistically valid in the simulation of the model. So again, as we move around, much like other Windows packages, you can zoom in and out on things, and you've got icons up above, normal Windows kind of toolbar. On the top, you can pan, you can set up grids. If you go into View, you can set up grids of various types, which are helpful really just in aligning your process modules. So they don't really affect the simulation, but if you are doing something for a presentation, it sometimes is useful to utilize that, be able to snap modules to various points, sort of lines things up a little bit better than if you just do it by sort of by chance with the cursor. So the modules, again, sort of the basic building blocks, the flowchart and the data are the two basic modules. You've got blank modules on your project bar that you can add a flowchart module enables you to add a flowchart module to the model. It's very straightforward, and I think everybody's sort of gotten this. I know there was some confusion with a couple people early on, but basically you just grab it, drag it, and drop it, and that's the way that works. Again, if you had a grid turned on, you can drop it on the grid, snap it into a location, and then line up other modules as well. So the flowchart modules, for the most part, are set up to describe some sort of a dynamic process. In other words, there's something happening in that process. There's a resource being consumed many times. There's an entity being processed in some way. There's a decision being made. Obviously, with the decide modules, the batch and separate modules, again, are a common manufacturing thing. Just to step back maybe for a second on that. Many processes, if we think about a common manufacturing process, say we're making some sort of widget. So we've got a plate and we're drilling a hole in it, and then it gets heat treated. So the first step of that would be to take that blank, bring it into a drill press process, drill a hole in it, and then send it out for heat treat. And a heat treat is a batch process. You don't typically heat treat a part at a time. Where drilling, you do. You typically drill a part, take that part out, put it in a bin of some sort, grab another blank, drill a hole, and so on. Where heat treat is not like that. Heat treat, you would batch up maybe 100 parts, and then you would heat treat those. So in that type of a process, or that type of a simulation, what you would do would be, again, have a process for the drilling operation. You would take that and then go into a batch operation, and you would batch whatever number is appropriate, maybe 100 parts, send it into another process, which would be the heat treat process. Again, consuming a resource, may not be a person necessarily, because it may be automatic, but maybe on a conveyor, goes into an oven and the conveyor comes back out again. But you would still have a resource for that equipment, if nothing else. And then coming out of that, you may decide that you're going to keep those parts in that batch of 100 and ship them in that state, or you may say, no, I want to separate that batch up into discrete entities and then go into further processing, maybe some sort of a deburring operation or a cleaning operation that's done to each separate entity. So that's sort of an example or use of that. And I think we've done a couple simulation models. If not, I'll put one together and pull that out in the next lecture. And there's other panels that can do things as well, other more less common, more specific type things. The useful thing about this is the flowchart aspect of it. One of the things that I had looked at was if there are any other simulation packages that might be more appropriate for what we're trying to do here. My only issue really with Arena is that it's really costly. So when you get into a commercial situation and you're working as a manufacturing engineer, let's say, and you propose to your management team that you'd like to buy a piece of simulation software, Arena's pretty pricey. So I was looking for something that was either lower cost or even freeware. And there are some out there. The problem with them is they for the most part, don't operate in this flowchart kind of system. And the benefit of the flowchart system is that you've got a great visual. You can see the process. You can physically see entities going through the process. And it's pretty straightforward into getting in enabling you to get into something called value stream mapping, which we'll talk about later in the semester. But value stream mapping, just to sort of introduce it a little bit here, is basically a flow chart that you create of a process, and it could be any kind of process. It could be the drilling, heat treating process I just described. And it's a visual. It shows each process, shows the flow between processes. The value stream part of it comes in as you look at each process and look for value added, and you classify things as either being value added or non-value added. So an example would be in our previous process, the heat treat would be value added, the drilling would be value added. The process of batching the parts, physically moving the parts, is not value added. It doesn't add any. If you look at sort of the value that you've put into the part, if I take a blank and I drill a hole in it, I've added value to it because it's closer to being a finished product. So it's closer to being able to be sold. Same thing with if I heat treat it. I've got that part closer down the pathway to being a part that can be sold, which is what it's, what the goal here is, right? So it's adding value. But moving parts from one place to the other, it hasn't added any value. I've not added a feature. I've not enhanced a characteristic, which is what heat treating does, makes a part stronger. So you separate then into these value added and non-value added categories. And then what you do is you try to eliminate or minimize the non-value added processes. You normally can't, well, I shouldn't say it. Many times, sometimes you can completely eliminate them, but many times you're just going to reduce them. You still need to move things from one place to the other, but maybe you can do it more efficiently. Maybe you can get some sort of a automated system that'll do that. Maybe you can get a conveyor belt that'll move the parts from one place to the other. So you don't have a human with a tow motor or forklift moving pallets of parts around. So that's why I like this process, or like this simulation package. And until I can find one that'll run, on a normal 64-bit machine, we'll stick with this. But the ultimate, that's really the reason why is it facilitates the use of value stream mapping, which is sort of an end result many times of simulations like this. And as I talked about earlier, if I want to edit things, I can either just double click it and up pops a dialog window that I can pretty much edit anything about that process or about that module, whether it's a process module or a dispose module or a decide module, whatever it is, I can edit any of the characteristics that are part of that. And that's an easy, many times the easiest way to do it. The other way is to go down into the spreadsheet view and edit it in that sense. So the data modules are much like the modules we talked about up above. The only difference being is there's no connection. They're not physically part of the flow of entities through the system. So they're for doing things like setting variables, system-wide things, setting schedules, establishing resources, looking at queues, things like that. Things where you're setting global kind of data for the simulation is a good example of that. And again, the only difference being is you're still doing something to the simulation. You just don't, there's no flow going through. You're setting some sort of outside of that flow, you're setting the data. And again, these sort of look like little spreadsheets, can be edited the same way. Typically edited in a spreadsheet view is most times the easiest way to do that. So the relations among the modules, the thing that sort of ties these together is things like queues, resources, entity types. In other words, a queue is typically in front of a process, but it can also be used in a decide module to make a decision based on the size of that queue, either downstream or upstream of the process that the queue is related to. Same thing with resources. I can have separate resources for each process, or I can have a common resource for each process. And obviously has a big impact on the model when you do that. If you have one resource, if I have one person doing 3 processes, obviously my capacity is less than if I had 3 people, 1 for each process. Entity types, again, are things that I can change and have unique names, variables, same way, expression sets, and there's others. And what the point of this is that these names, they need to be managed, because you need to, typically you would set up separate names for each process. It could be process 1, process 2, or it could be more descriptive and say drilling operation, heat treating operation, whatever you choose. It doesn't really matter as long as they're unique and that you manage them properly, not that you've got a resource that you're not aware is actually in 2 or 3 different processes. And the reason I want to focus on this a little bit is this is one thing that I identified, or observed rather, in quite a number of people of simulations that were being done. They would just leave the default resource rather than having a specific resource for each process that they did, which is a more common situation. If if you were sharing a resource among the entire simulation, you sort of losing some of the value of that simulation, because that probably wouldn't be a good, accurate, robust model of the finite model of the actual physical process. So real important to keep track of those. Another place where the spreadsheet view is very helpful, because you can pop that up, and if you've used a unique name that actually describes the process, like drill the hole, like heat treat the part, it becomes real easy to look at that spreadsheet of your resources, especially as you get into more complicated models. And you can just do a quick visual and say, "Yep, I've got resources set up for each of the processes, and I've got separate queues set up for each of the processes." So, just an important point there to sort of manage your variables, your entity types, make sure that you're, you've got a accurate, high resolution kind of model that's set up for your physical process. And Arena uses these and presents them to you a number of ways. You could look at each process or each module, but the easiest way, again, is the spreadsheet view to look at that. So again, Arena keeps that internal list, and the important point of that is that internal list can then be accessed by other modules. For example, queues, or even resource utilization. You could look at that variable, basically what it is, and make a decision based on it. So it maintains that for you. Same way as if you set up a record, if using a record module, if you set up a variable of something that you want to look at, whatever it might be, you can access that and make decisions on it as well. So if there's some unique things to your process that aren't captured with the standard set of characteristics that Arena captures and keeps in a database, you can establish your own and then just utilize those, again, further in the process or further in your simulation to to make decisions on. And again, this another important point here is it is across different types of modules. So in other words, when I set up a variable, let's say, that variable can be accessed by any number of modules. It can be accessed by a batch module to tell me to batch or not to batch. It can be it can be used by a process module, by a decide module, by an assign module. So any of the modules that are out there can access that data point. So again, you don't need a set of resources and only worry about those in respect to your processes. They can also be used elsewhere. So they need to be, again, managed sort of simulation wide, if you will. Okay, so on the internal documentation of the model, there's a way to look at the data is basically just to hover your mouse over the object, and it'll pop up with the pertinent data that is contained there. And again, not just the standard Arena data sets, but also anything that you might define as a user-defined situation. Project description, again, you can enter that or should enter that, some unique name, whatever you want to call it, something that describes it, and that's in your setup of the initial simulation. The documentation report, there's a lot of different things that you can do with that. You can add some graphics. We're a little bit limited with the student version on that. I looked at some of the new graphic pieces that they've added, and unfortunately we have a limited selection. You can only pick like one out of each category, so it's a little bit limiting with that. But if you had the full version, you can do a little bit more. But in terms of the documentation report, you can generate a full report. The graphics, to be honest, are somewhat of a, not all that terribly useful, to show a picture of a drill press. I mean, to some extent maybe it is, and you can drop things in if you wanted to create your own, and this would be actually probably more useful. If you wanted to create your own sort of images, you can do that and drop those into into your documentation report. We don't focus on that too much here. I really try to focus on using the simulation tools, understanding the underlying statistics behind it, and not so much on creating a glitzy report. But you can do that, just so you're aware, and it's fairly straightforward to do. And if you're using it in a commercial application, that would become a little bit more important in that you're trying to explain what you're doing to people maybe that aren't fully up to speed on it. So sometimes a little bit more glitzy report can help that. So again, just run through the modules real quick, and we've done this, but I want to again just review it because this is sort of the base of the system. So we all need to at least get to the same level of understanding, if you will. So the first module always in your simulation is going to be a create module, and that's sort of where the entities are born, if you will. So this brings the part into the system. Pretty much the only way to do it. You can have multiple create modules in a simulation. A good example of that would be we'll do some assembly stuff a little bit later in the semester, and we'll have multiple parts that we're bringing into a system and then assembling them together. So that's a very common manufacturing thing. You've got 4 or 5 parts that come in, you assemble them together, and you ship it as a finished product. So that's how you would do that. Again, it would be with multiple create modules. And again, that's the only way to get entities into the system. There's always going to be a create module. That's never, so that makes it sort of easy. If you're starting on a simulation, you know the first thing you got to have is a create module. And the property dialog window that comes up gives you basically the opportunity to name that, which is again important to do if you've got multiples especially. And you can call out what entity type you've got. And normally you would name that something that means something. So if I had, say I had a bracket coming into the system, and I had a plate coming into the system, and then a bolt and a nut coming into the system, and I'm going to bolt the plate to the nut, or bolt the plate to the bracket rather, with the bolt and nut, I would name my entity types: bolt, nut, bracket, plate. And that just gives you a good visual again of what you're actually getting. So that's the entity type, important to sort of bring that into some sort of a useful name that you can use in the simulation. So then the next thing that you need to define really is your time between arrivals, right? So there's a whole bunch of different statistical distributions that you can utilize to do that. You can do it either with a statistical distribution. You can set up a schedule. You can have it constant. So in other words, a part comes in the system every minute. And that may be useful if you've got an automated portion of your process where it's going to happen every minute, or it's going to happen every half a minute. If it's something that a person is involved in, typically you're going to use a statistical distribution, again, because people aren't robots, so they're not going to keep that constant. There's going to be variation, and it's important to accurately model that. So sort of a rule of thumb, if it really is constant, in other words, it's coming from a robot or it's coming from some sort of a part dispenser that is going to dispense parts at an absolute constant value, you can utilize that. Otherwise, you're probably going to either use a distribution of some sort, or a schedule, or possibly an expression where you're going to set up sort of an algebraic type expression that maybe is dependent on other things in the process. Maybe you're going to look ahead to the next station and say, well, I'm not going to bring a part in until that station is free. That would be an example of using an expression to help with that. So that's also possible. And then you need to define your units. This is another place where I saw some issues, is that you need to stick with units. Whatever your units are, you need to sort of stick with them throughout the process. Arena does manage, to some extent, switching between units, so it knows 0.5 hours is 30 minutes. But it also, I've seen it also cause some glitches in the system. So just a sort of word of advice, I would keep whatever units you pick with your create module, keep those all the way through the system. And then finally, your entities per arrival, you can again sort of batch coming into the system. So I can say I've got 10 entities that are arriving at a time. Again, sort of you're not really using a batch module. You're sort of doing it right in the create module, but it's the same end effect. You'd get the same effect. Let me put it this way: is if you had one entity per arrival at your create module, and then right after create module, you put a batch module with a batch of 10. You would get the same end result. Okay, so you can sort of combine that into two modules to make things combine those two modules into one to make things a little bit easier. First creation, and again, max arrivals, you can set that to whatever number you want, and that's one way to control how long the simulation runs. The first creation, I've not seen occasions where you wouldn't make that 0.0. That basically is the start of your simulation. You can delay it though. If there's a reason, I'm not sure what that might be. Maybe you've got some sort of a startup thing with a process that it takes 15 minutes to heat up or something. That might be an application, I guess, but I've not really utilized that other than at 0.0. But you can change it if you need to. But be aware that your simulation will start and then nothing will happen, at least with those entities. They won't start coming in until it reaches that time. So if I set that, say I'm using hours as my units and I set that for 1 hour, my simulation is going to run for an hour before an entity comes into the system. So if there's a reason for that, and maybe a startup condition might be, that is normally, as I said, 0.0. So that's your create module. And again, I think I sort of ran through this already in terms of entity type, entities per arrival, max arrivals, and then first creation. And again, it doesn't need to be 0 as it's stated here in the notes, but I've not seen a whole lot of applications where 0 doesn't make a lot of sense. Okay, so again, we talked about the ability to edit these things in various places. And I can edit in the flowchart module, which sometimes is the most straightforward. Or I can do it in a spreadsheet module, and depending on what you're doing, you'll just sort of be aware that you can do it either way. And there's occasions where one way is easier than the other. The spreadsheet I find to be most useful when I'm trying to look at multiple resources or multiple schedules, and make sure that they're all sort of lined up with each other. If you get an error when you go to run, sometimes the first place to look would be a spreadsheet, because it'll give you everything and it highlights the error, changes the color of the box that the entity's in, and or whatever is in there, wherever the error is, if it's a name or if it's a type of distribution or whatever it's not liking about your simulation, it'll highlight that. So that's again a useful place to sort of look. And again, the expression builder, that's as we get more complex simulations, that's a useful thing to use, is the expression builder. So the data module, again, is only editable in the spreadsheet view, and this is much like the other modules, except it is not connected to anything. So if I want to go in and establish, so let me back up a step. So the entity, when you run your simulation, I'm sure you've seen this, you'll see the entities physically going, especially if you have the speed set low enough, you'll see the entities physically moving across your screen from module to module and building up in queues, okay? Well, I can change that picture to make it something that's more useful to me. And you know, typically it's not going to be something that's actually going to look like the product maybe that you're doing. But for example, I could have coming into my systems, into the system, a blue ball. And then maybe I'm going to go through a couple process modules and then go through a branch where I'm going to take that branch and take it somewhere else into a different process, or back in a rework loop was one of the examples I used last time. So it's really useful then to take that picture and make it a red ball or a yellow ball or whatever. Doesn't matter what it is, just so you can see that there's a difference to it. Another useful place for that, and I think I did this in the last lecture, was I used the priority feature, where you know, by default it's first in, first out of a queue. But I can change that by establishing a priority. A useful place for, and in that case, I might want to change anything with a high priority, again, to a different color, just so I can see that it's different, see that I've got something different going through. A place we've utilized that is in some of the, and we'll do more of this, but in some of the urgent care simulations. If you have someone, come in with a more significant medical condition or issue, you can set a priority to where they'll get seen first. So in that case, you might want to change the color of the entity. Again, doesn't really affect the simulation at all, but it just allows you to see it. If you're using the same picture all the way through, that little icon that signifies the entity, if you use the same thing all the way through, you can't see it. It'll still work right. In other words, that entity with the higher priority is going to go basically to the head of the line, and that's what's useful to see. Is you can see a queue of, say, my normal condition is all blue balls, right? And my higher priority is a red ball. When that entity comes up into that process, you'll see that red ball shoot right up to the front of the queue. And it's just useful to it's a useful visual to be able to see that this is what is really happening. But again, it doesn't affect the simulation. It's just a visual that's useful when you're trying to debug something or actually make sure what's happening is really what you want to happen. And then the process modules. So again, that's a one that you're going to use all the time. I can't think of a simulation that wouldn't have a process module in it, because that's where the resources are applied and the actual work or modification or whatever's being done. That's where that actually happens. Any place you service an entity or modify an entity, you'll use a process module. So the key points of that, again, a name. So I give it a name, something that means something to me, that means something within the context of the simulation. I pick whether it's a standard process, which for what we're doing now, the other option is to make it a submodel. And we can do that. It's basically creating a little subroutine, sort of outside of the standard simulation. But for most things, you're going to have a standard type of a process. Your action is going to be either delay, seize delay, release, or delay release. For what we're doing now and pretty much through the semester, keep it at seize delay release. That seems to work the best for the type of stuff that we're trying to do. And what that does is it takes the resource, it holds it until that entity has been processed, and then it releases it. So the other is you need multiple process modules to accomplish a given process. So for now, at least, use the seize delay release. The priority, again, you can set low, medium, high. And then finally, and then your resource, you need to add a resource. Again, call it something that is meaningful. And you define the units of that resource as well in that resource column. And the other reason to use seize delay release is if you use delay or if you use the other ones, you can't attach a resource to that process, and that's many times a useful thing. You want to look at resource utilization. You need to attach a resource, so that's important. And then finally, the distribution, or how things are processed through that process, is your last box there. And it can be, again, a statistical distribution. Again, you've got units, same thing, keep them the same. You can do a little value stream mapping right within Arena in allocating whether or not the process that you're looking at is value added or non-value added. Very useful tool. And then for your distribution, and what we use a lot is triangular, because it's very simple and it's very straightforward. It's a simple triangular distribution. You've got a most likely value, a min value, and a max value. So that one is just used a lot because it's very easy to manage. Similarly, in a lot of statistical uses of statistical distributions, you'll see people use normal distributions, and that's another one that can be used. In that case, you simply specify the mean and the standard deviation. So those two are pretty easy to use, and they reasonably approximate a lot of physical processes. Not 100%, but they reasonably approximate. One thing I'd like to see you start doing too, as you're doing these models, and say you get the thing to run really good with a normal distribution or with a triangular distribution, whichever. Change it to a normal or change it to a triangular, depending on what you started with, and keep the values roughly the same. So the most likely value would be your mean, and then you'd calculate, if you had a triangular, you'd calculate an approximate standard deviation that would approximate the range that you've got, and see what happens to your model. Does it still run without building an excessive queue or without winding up with a processing time that's outside of an acceptable time frame? Basically trying to bust the system is what you're really trying to do. And if you can get that to run with various sort of similar distributions, you can have a higher confidence level that your simulation is in fact a good approximation of your actual physical model. Because to be honest, it's difficult many times when looking at actual data to categorically say that, yep, this is a good normal distribution approximation, or it's a good triangular. You can sort of get close, and you can sort of pick, some you can pick out easily. You can easily pick out if it's a constant distribution, things like that. But some of the others, it's sort of in the weeds a little bit as to whether or not it's a normal or a triangular. So try both with similar values for the values that you're using. But it's just a good tool to sort of get a confidence level in what you're trying to do. Okay, so that's the process module. Again, you've got the flow chart. Look at it, and we sort of went through that already. The seize, delay, release, again, is the most most common. Some of the other examples they give there, a delay would be example of a traffic light. So you're not using a resource or queuing. You're just sort of hanging out for a given time duration. Seize, delay, again, you need multiple process modules then to describe your process, because you need to release it at some time, at some point, and you'd have to do that downstream. And again, the delay release would be sort of the converse of that. That would be to delay. So if I had two process modules, I could seize the resource in the first and then release it in the second. And I'm sure there's applications for that. I've not really come across any that wouldn't just fit with a one process module, a seize, delay, release, but it's possible. Maybe you've got different statistical distributions for the seize and for the release. I'm not sure how we would utilize that, but it's out there, and I think at some point we'll stumble across a physical model that will sort of wake up and say, oh yeah, that makes sense. But anyway, seize, delay, release, that's what I would use for the most part. And then the resources, again, and you can have multiple resources, you can have multiple quantities of a resource. I use my drill press example. I could have multiple drill presses and then manage it that way. So it's sort of one batch of drill presses, if you will, that would sort of just take the work as it comes, looking at it as one process. The other way I could do that would be to have multiple drill presses, each one of them being in its own process module, and then route to the drill press based on the amount in each queue. And we'll talk about that a little bit more as we get into decide modules and looking ahead at variables. But point of that is that there's almost always multiple ways to do sort of the same thing, and that's just depends on your situation, which might work better. So that's pretty much it for the process flowchart module. Again, don't forget your units. That's one of the more common things is to mix your units and then wonder why your simulation's not running so good. Okay, so we'll stop this lecture here at resource data, and I'll come back to this afternoon, so you'll be getting this shortly, and you'll get another lecture a little bit later in the day.